Oh, hey, I didn't see you there. Did you know how dry Australia is? It's so dry that in fact to this day most of its landmass is in drought, specifically the state of New South Wales. In the year 2018, New South Wales was defined as being entirely in drought under the Bureau of Meteorology's definition of drought. It can be suggested that lack of rainfall in New South Wales is related to temperature. It was hypothesized that low levels of rainfall are dependent on temperature, leading to the focus of the study. Can it be observed that mean monthly temperature in regional New South Wales affects its levels of total monthly rainfall? In this study, 5 towns in New South Wales along the Murray-Darling Basin have been selected as the sample. The towns of Brewarrina, Cobar, Menindee, Orange and Tamworth have been selected based off of their distance from the coast and proximity to the Murray-Darling Basin. In order to ensure the data has large distribution, the towns were selected based off of their distance from one another in order to get even spread across the state. The completed analysis of data can be categorized into 3 groups: supporting the question, opposing the question, and mixed years both supporting and opposing the question. Upon observation, it seems that the years 2005, 10, 11 and 12 all support the question and weather patterns recorded by the Bureau of Meteorology. In the year 2005, for example, New South Wales was in the median of the Millennium Drought, and trend lines present a negative skew, meaning that the increase in average temperature leads to a decrease in total monthly rainfall. The years 2010, 11 and 12 all show positive trend lines, which can be explained by the La Niña weather event that occurred in the sample towns throughout 2010 and 11. The La Niña weather pattern occurred due to equatorial trade winds becoming stronger and changing ocean currents, consequently drawing cooler water from the deep ocean. This string of events brought above average levels of rainfall to New South Wales, recovering water shortages from 26% to 80% in the Murray-Darling Basin in 1 year alone, 2011. This in turn brought down the mean temperature for the year, allowing for more total monthly rainfall, ergo supporting the question. To help us visualize the increase in rainfall over the La Niña weather pattern, histograms presenting the mean total rainfall of the sample towns of the year in 2011 and the most drought affected year in the whole sample being 2018 have been constructed as seen here. When we compare the rainfall presented in the histograms, it's clear to see that in 2011 more rainfall is present in comparison to the 2018 rainfall data. We can suggest that the years contradicting weather patterns can be explained by their geographic location. In the contradictory group, the years 2007, 2008, 13 and 17 all contradict the question. In 2013, for example, analysis of the trend lines in constructed scatterplots mostly show us that an increase in the highest average monthly temperature does not affect the total monthly rainfall. This can be suggested due to the positive correlation between temperature and rainfall shown in the trend line for the year. However, this trend line's positive skew is contradictory to the study focus, as it was hypothesized that an increase in temperature would show a decrease in rainfall, while analysis of the trend lines in the data mostly suggests the opposite. This statement can be confirmed as contradictory, as the data suggests an increase in rainfall for the year while drought actually returned to New South Wales in 2013. This can be seen in ABC's interactive drought map of Australia, which can be viewed in the link below. Most of the sample shows mixed supposition of the study focus, however, both supporting and opposing the question, being years 2006, 9, 14, 16 and 2018. For example, in the year 2006, it can be observed through analysis of the trend lines that 2 of the 5 towns supported weather patterns for the time. Although the other three towns contradicting the study focus can be explained by geographical location. As Menindee, Tamworth and Orange are closer to the coastline in comparison to Brewarrina and Cobar, it can be suggested that the two towns that support the weather pattern received less rainfall due to geographic location. Being further from the coast, Brewarrina and Cobar are expected to receive less rainfall than Tamworth, Orange and Menindee. Concluding this case study, it was observed that sample towns seem to both support and contradict the questions stated in the introduction. Bivariate analysis of the data findings shows us that the data obtained in some years, the studied towns show us that the levels of rainfall are dependent on temperature, whereas other years show the opposite correlation. Therefore, it can be concluded that the data partly supports the question and hypothesis. Thank you for watching. Do not like, do not subscribe.